Right, some of you have been finding the whole sort of charged particles in magnetic fields quite tricky to do, which it is, and it's something which would be a little bit easy to do in the classroom. So at the risk of being a little bit stupid, I'm going to try and demonstrate it here. So we're going to start off by saying that the field lines, which are the fingers, I'm using my left hand because it's a negatively charged electron, so the field lines are going from the bottom of the screen up to the top. They're the magnetic field lines going up, the way the pencil's going. So the electron is my thumb, so the motion of the electron is in that direction, and the field lines are in that direction. The force on the electron will be out from the screen as you're looking from at it. Okay. If the electron was to go in the opposite direction and go that way, then the force on the electron will be into the screen, pushing in that direction. Do the same thing with a positive charge, and everything reverses, of course. So right hand for positive charge, motion of the proton, fingers for the field, force would be the push. So that's the same. This time I'm going to have the field coming out of the screen as far as you're concerned. So the fingers are the field, the motion of the electron is the thumb. And what happens here, because it's getting pushed, it actually starts to go around in a circle because the electrons are always getting a push at 90 degrees to the way that we're going. If we did the same thing going away from, this doesn't really work, going away from the field going away and pushing in that direction, then it would tend to push downwards. No, it would push downwards like that there. Okay, so you've got to get used to this idea. Fingers field, thumbs the motion, palms the push, and that'll give you the force directions that you need. Okay, good luck.